The next problem on the list that I'd like to look at would be problem number 66. So again, I'm picking a variety of problems to make sure that I touch on every combination that comes up. Here I'm glancing at this. Well, obviously the right side is a 1. That's very simple. I'm going to work with the left. And I notice the left I have this cosine by itself, and I have a fraction in terms of tan and cotan. So at least I know I'm going to start by rewriting all of these tangents as sines and cosines. That's how I break all the problems. Oops. And I know this is sine of u. So most of the time, if I see some kind of algebraic manipulation, that's where I begin. At least it's a starting point. And believe it or not, it turns out to be what you need. Well, if I take this right here, and the LCD for the top and the bottom combined is the sine cosine. This is missing a sine. I multiply top and bottom by that. This is missing a cosine. This is missing a sine. And this is missing a cosine. And I will ignore those denominators since they are the same. This is from algebra. This is something that's coming up in calculus heavily. So the top is really sine squared of u minus cosine squared of u. And the denominator, which is this, you just read the top, and you just read the denominator. And that would be the sine squared of u plus cosine squared of u. And I notice here, there is a twice cosine squared of u. I don't know what to do with that yet, but I noticed that, hey, this is the famous identity. That's a 1. So I'm really looking at the sine squared of u minus the cosine squared of u plus twice the cosine squared of u. And wouldn't this be negative cosine squared of u plus 2 of those? Isn't that one of those? And we're back to the magic identity. Sine squared of an angle plus cosine squared of an angle is a 1, which is what I want. So again, if I see squares, I will start with the Pythagorean identity. There are only 3 of them, those 3 identities. And if I see linear, I'll try to write everything in terms of sine and cosine and proceed. The next problem I want to look at is number 78. And glancing at that, the left side, not much I could do. It's sines and cosine. The right side, I noticed that there's a square. I have a couple of options. I could say, you know what, let me start off by writing everything in terms of sine and cosine. The reason for that, I see that there are only sines on this side. So isn't this 1 over the cosine of theta? And isn't this sine of theta over cosine of theta? Wouldn't that be a single fraction since the denominators are the same? And if I distribute the square in, isn't that the cosine squared of theta? And the top, isn't that 1 plus the sine of theta squared? Now keep in mind, even though I'm not supposed to work with both sides, but I could see that this is right there. And I noticed that this cosine squared, there is no cosine squared on the bottom. So keeping an eye on both sides of the equation would be the smart thing to do. I want to know what cosine squared equals, and what do you think cosine squared equals? Wouldn't that be 1 minus sine squared? And isn't that the difference of squares? Isn't that 1 minus the sine of theta into 1 plus the cosine of theta? Kind of like saying a squared minus b squared. Isn't that a minus b into a plus b? And wouldn't this, okay, I'm getting carried away, sine of theta, wouldn't this cancel with one of those? And you're left with 1 plus the sine of theta to the 1 over 1 minus the sine of theta, which is exactly what I want. So it helps to keep an eye on both sides of the equation. That would be the wise thing to do. Okay, how come that's not working? There, much better. I'd like to look at two more problems. I want to look at number 94. Oh, look at that beauty. Oh, I don't think I could fit it there. Okay, I'm going to fix this. Just let me pause. Okay, we're back. Well, I decided to do it 100 first, then we do 94 after because of the spacing. I want this to look, nice. So I'm trying to figure out what this... Of course, I can start with the right-hand side, so I'm trying to figure out how to do this. Well, the left side is the way to go. And what do we know about 2 logs with a positive in between? What do you know about natural log of A plus natural log of B? Wouldn't that be natural log of A times B? Of course, assuming A is positive and B is positive. So wouldn't this be natural log of absolute value of secant of theta plus tan of theta times secant of theta minus tan of theta? And if I look at those a bit closer, I notice that those are the same thing with opposite signs. Those are called conjugates. So I'm going to get the first squared minus the second squared. This tells me that, you know what? I could figure out what secant squared equal, and it's right there. What would secant squared equal? Isn't that tan squared of theta plus 1? Wouldn't that be tan squared of theta plus 1 minus this tangent squared of theta? Wouldn't these two cancel out? And I'm left with natural log of 1. And what's natural log of 1? And there it is. What do you know? The last problem I want to attempt is problem number 94. And again, I'm getting a 0. Not sure how that's going to happen. Well, let's see. If I play with this, first, I could change everything to sines and cosines. Or I could say, you know what? Let me just FOIL. That's tan of alpha minus tan of alpha, cotan of alpha, cotan of beta, plus tan of beta minus cotan of alpha, tan of beta, cotan of beta. And if I get to the second, plus cotan of alpha minus tan of alpha, cotan of alpha, tan of beta. And maybe, I don't know what color to use. Let's go with that one. Plus cotan of beta minus tan of alpha, cotan of beta, tan of beta. And if I try to figure out, do I see anything matching this? That's positive tan of alpha. And I'm trying to see if there is one. Well, it doesn't look like it. Okay, then one more step. One more thing I want to point out. Tan of alpha minus. Look at those right there. Isn't that tan of alpha? And this is 1 over tan of alpha? Here. Isn't that cotan of alpha? And this right here is tan of beta. And this is 1 over tan of beta? Here. Isn't that 1 over, isn't that tan of alpha? And this is 1 over tan of alpha times tan of beta. Just be patient with this and work a bit slower than I'm doing. I'm trying to finish before the time. You should work at this a bit slower. This is 1 over tan of beta times tan of beta. And notice what happens. Those cancel out. I'm left with tan of alpha minus cotan of beta plus tan of beta. Those cancel out. Minus cotan of alpha plus cotan of alpha. Those cancel out. Minus tan of beta plus cotan of beta, that's this, minus tan of alpha. And now if I glance at those, I'm looking for a tan of alpha. There's a minus. Those cancel out. I'm looking for cotan of beta. It is right there. One positive, one negative. They cancel out. I'm looking at tan of beta minus tan of beta. Those cancel out. And I'm looking at negative and positive. Those cancel out. All of these cancel out, and I am left with a 0. So a bit long, but not that hard if you just follow the steps. Let me list the homework, and there's the homework. Page 126, you're going to do numbers 21 through 99 every other odd. Skip number 61 and 89. Did I give you a page number on this? Sometimes I get carried away. Yeah, there it is. Page 8. That doesn't look pretty. We have time to write that down. This is on page 126. And there's the homework.